this again. Come. Okay, hi everyone. So, for those of you who don't know me, I'm Miss Ho, your physics teacher. All right, and the reason I'm taking this video is in anticipation for my absence for the lesson, which will be happening this week. But I don't want you to miss out too much. So that's why I'm taking this lesson recording. And hopefully that will help you so that you can understand what's going on and you'll be able to solve the questions. All right. Before watching this video, though, you need to watch the video on resolution of forces, which I will share in the link up there, because you need to understand what resolution of forces is first before we can look at examples. In this video, we're going to be focusing on the examples from your textbook. So you can open your textbook to pages, let me see, pages 15, 16, and 17. We will go through examples 1 and 2. So I have in this Jamboard already set up only the diagrams because I want to explain the concepts one by one, right? So this is example 1, and you can see in example 1 we have over here a wooden block where there are 4 forces acting upon it. We have the weight W, normal reaction R, friction Fr, and there is a tension force because we're pulling this block with a string at an angle of 30 degrees. So this T is tension. Okay. In this question as well, they gave us the values of the forces in this table, which we will take a look at as we are looking at the solution to the example, in the questions in the example. So, looking at example 1, it starts off with A. Calculate the magnitudes of the horizontal component and vertical component of pool T. So, if you have already watched a video on resolution of forces, you would know that to resolve the forces, it means to, if I were to draw it here, let's say force F, you need to resolve it into horizontal and vertical components. Horizontal component means parallel to x. So this would be Fx and this would be Fy. What we're trying to do is we are trying to make a right angle triangle with F as the hypotenuse. Fx and Fy will be perpendicular to each other. So we get this right angle triangle. We're going to do the same thing for t, but because this is t, not f, that means we can label this as tx and ty. So this is tx and this would be ty. I'm going to rub off this from here because we don't need this at the moment. Okay. Now, to resolve tx and ty, because this is a right angle triangle, so we can see that we can make use of trigonometry, SOHCAHTOA, to solve tx, ty. So Tx is adjacent to the angle 30 degrees. So we have Tx over hypotenuse T, and adjacent over hypotenuse is what? Cos, correct. So this gives us cos 30 degrees, which means that you can solve Tx, bring this up as T cos 30 degrees. And from the table, we find T is 36 Newton. So you can you can substitute 36 into T, 36 cos 30. And from there, when you work it out, I'm just going to look at the textbook because I'm malas, okay? Yeah. You get 31.18 Newton. You approach the same method for ty, but ty is opposite to 30, right? So if we have ty over t, opposite over hypotenuse is sine. So sine 30, ty is t sine 30. Substituting, I'll just put it here because no more space. 36 sine 30 half, that's how you get 18 Newton. So this is how we solve the horizontal and vertical components. Oops, it's not showing up. So Tx is the horizontal component. I'll just indicate it over here. So this is the horizontal component. And Ty is the vertical component. And by the way, in case you're wondering, yes, my class is here. So if you hear any noise, it's from the class. Okay, so this is the answer for A. I'm going to write that down. That's answer for A. Okay, I'm just going to reposition this because it looks so terrible. Horizontal component. Okay, this is actually the horizontal component, and Ty is actually the vertical component. So that's how we solve horizontal and vertical component. You're basically finding the x and y components of that force. The next question is to determine the magnitude and direction of the resultant force acting on the block. So, the reason why we want to find Tx and Ty is because now, if you look at this diagram, you'll find that it's hard to solve it with the original forces, right? Because you have WR, okay, you know, there are opposite direction to each other. And if you look at the horizontal, though, you're like, wait a minute, there's a force acting at an angle here and makes it so much more difficult. You're like, huh, how to solve this, right? So the reason why we want to resolve the forces is because by getting forces that are all in the same directions or parallel to each other, it makes it easier to solve. So I'm going to show you what I mean in the next slide. Okay, I'm just going to draw the object here. Okay, let's say like this, all right? And I'm just going to label all the forces first, like a free body diagram. We have W. Let me just check what we have. Friction is here. Whoops. We have R. Now, before I go put in T. So if you recall, when what we learned about resultant forces was if you have two forces acting at an angle, and then what happens is if we find the resultant force is equivalent to these two forces, which means you can throw away these two forces and replace it with a single resultant force. Now, the concept of resolution of forces actually is also the same. That means if you have force F and you get Fx and Fy, you can throw away F and keep Fx and Fy. That means this is equivalent to these two, just like how this is equivalent to these two. So what we're going to do in this case is we are going to throw away the force acting at an angle and keep the horizontal and vertical components, which are Tx and Ty. Why we want to do that, I'll just put Ty over here so that it's easier to see. It's because now we have the vertical components all parallel and the horizontal components all parallel. So if we want to solve, it's easy because now we can just like, oh, these two plus together minus this. So let's talk about let's talk about the vertical component first. So we have vertical forces, are not components, right? The vertical forces. If we compare, let's say going up as positive and going down as negative, not compare, sorry, let's solve it. So that means you'll have R plus Ty minus W. And how you solve it, okay, do we have R? Yes, we do. 6 plus Ty, which is 18, minus W, which is 24. You calculate this out, you're going to get 0. In fact, for you to understand, right, where did they even get the normal reaction of 6 is because the weight will be balanced by Ty and R. Because under normal circumstances, you know what we've learned in the previous topic, W should be equals to R. But now we have an additional force of Ty. Ty will lessen the normal reaction. That's why the normal reaction has dropped to 6. So if the object doesn't move up or down, if it stays level, it doesn't go up or down, that means all this has to be balanced. And that makes sense, right? That's why it all equals to 0. Horizontal forces, let's solve it now. If we take going to the right as positive, that means the horizontal force, resultant force, resultant force in this case should be Tx minus friction. And Tx, we already know it's 31.18. So it's 31.18 minus a friction of 20. And that's how we get 11.18 Newton to the right. So this is the resultant force. I didn't write that out, so I'm just going to write that resultant force. 0, so which means you can ignore the vertical force because 0, right? So in the end, the only resultant force acting on the object here is 11.18. So this is not even the answer. I'm just going to rub that off. Okay, so that's how we solve the resultant force. Just to let you know, if if you got a non-zero value for vertical forces, you'd have to count the vertical, horizontal, and then resultant force from that. That means you have to solve the triangle method or parallelogram method. In this case, because it's zero, we can ignore the vertical and focus on the horizontal only. Next question is to calculate the acceleration. Let me create one more slide. Okay, so to calculate the, whoops, sorry, wrong pen. To calculate the resultant force, sorry, to calculate acceleration, we use F equals ma. F is the resultant force which we had already calculated as 11.18. The mass is given as 2.4 in the textbook. To count A, you just bada bing bada boom, 11.18 divided by 2.4. That gives you 4.66 meters per second squared. And that's how we get the answer. Ta-da! Easy, right? Yeah. Now let's go on to example 2, which is this. Now, the example 2 is a bit unique because this is a situation where the object is placed on an incline. So an incline means it's on a slope. So if you have a object on an incline, this pinjam sikit, on an incline, an object, when you place an object, what happens is it's going to slide down, right? Any object you place on an incline is going to slide down. And the greater the incline, the faster it's going to slide down. And that also depends on whether the surface is smooth or not. So in this question, if we look at the textbook, it does say it's smooth. Now, remember, what does smooth mean? Right. Smooth means no friction or negligible friction. Looking at this diagram, they've already drawn a few forces for us. We have the weight, and we know that the weight is always going to be following the direction of gravity. So weight is going down. But the thing is, the object doesn't move down this way because the plane is in the way, right? So what happens is the block is going to slide down this way. Just going to move it a little bit. Okay, the block is going to slide down this direction. So this concept is known as inclined planes. An inclined plane just means slopes. Incline means like a slope. All right. So this is an inclined plane question. So it's a little bit tricky. It's not as straightforward as example one because of the way this is moving. Now remember that if we're solving forces F equals ma, now if the formula has vectors in it, the vectors must all be in the same direction. So if the object is sliding down this way and it's moving with acceleration, that means there's a force making it move this way. So we need to find the force in this direction, right? That's what this whole thing is about. So before we get started on finding that force, let's look at the question first. The question asks us to sketch the component of the weight of the block parallel to the inclined plane and perpendicular. Like apa ni, what are you talking about? So in a nutshell, it's just like this. Under normal circumstances, right, if the force was acting, at this direction, F, and we need to find the horizontal and vertical component, you have to wait for Alia to come back. You see, the force is always the hypotenuse. Oops, that's not straight at all. Okay, so this is how it would normally be. So which means that I'm just doing this, I'm just copying and pasting because I want to be able to rotate it. So I'm going to rub this off because I don't need this anymore, but I'm going to keep this copy diagram because you see what happens is we can actually rotate this if we need to. Oh, I didn't rub off the X. Let me get rid of that. Okay. So you see, what we need to do is we need to create a right angle triangle from the force line where the force is the hypotenuse. Now, some students will tell me, teacher, we already have a triangle here. You see? Ta-da! Look at that. We have this. Now, this cannot because why? This is not the hypotenuse. This is the hypotenuse. Now, you see, right? The hypotenuse must be the longest line in the triangle because from F, we get Fx and Fy. So if suddenly you get this on this, you put a weight over here, and then you have a hypotenuse that's longer, that means you're going to create a line that's longer than the weight. And where does the extra weight come from? Extra force come from? Tak boleh, cannot. The force line that we're going to resolve must be the hypotenuse. So this is actually equivalent to doing it like this. That means this weight line is now the F. Oops, I'm blocking now. So we're going to have to find this and this. And the force making the block move in this direction is actually Fy, kind of lah, okay? Yeah, you can see. So I'm just going to put it one side here so that it doesn't block the way. That means we're going to draw this triangle now based on this shape. Okay, how? Okay, I'm going to draw this a little bit bigger so that, not like that, okay? So that you can see, all right? So let's say this is the block. And I'm going to rotate it and place it like so. Now the weight line must still be downwards. That doesn't change. But we're going to make the weight in as a hypotenuse, right? So kind of like this, right? So how? We are going to create a triangle now. So what happens is I'll just use a different color for clarity, okay? From this point, we draw a line that is parallel to the inclined plane surface because this is the force that will be pulling it down in this direction. Because acceleration going down this way, so the force must be in this direction. Now, if you don't know where to stop, never mind. You can draw a bit longer first and we can erase. The second line has to be perpendicular to this line because we're going to make a right angle triangle. That means from here, like how? Perpendicular. So you get a perpendicular line like this. Then you can rub off. Now, the arrow of the weight is moving down. So, going down, right, that means this blue line arrow is this way. We will call this WX. And this one is this way. We will call this WY. So, this is how we can draw the components. This is answer for example 2A. Next, we need to determine the resultant force acting on the object, right? Okay, so once we have this, I'm just going to draw again. Let's go to this slide. I'm going to take out the weight line now. Not that you have to, but it's just that for clarity, all right? Because remember, like example 1, I threw out tension and I just kept Tx and Ty. In the same vein, we can also do that over here. So that means we're going to have wrong pen. WX and we'll have WY. And then now, what happens is you'll find that in the origin diagram, let's talk about normal reaction. There's a normal reaction here. And where did it come from? Remember that normal reaction is 90 degrees to the surface. And this normal reaction is in response actually to W. Just to let you know. Okay? Oh, I haven't even talked about the calculation yet. My bad. Okay, so coming back here, let me just do this. Okay, let me create a blank slide here. Okay. Okay, I'm doing this because I malas to draw again and we need a triangle. Now, based on the original question, the value of the angle is given here as, how much was it? 60 degrees. Okay, so I'm just going to write that down. Okay, this is, 60 degrees. Okay, here's 60 degrees. Okay, it's very big because I draw it here, right? Okay, so how does this 60 degrees affect this triangle? This is how. You can see, right, if this is 60 degrees, can you see that there's a triangle here? This is 90 degrees. This gives us 30. And these two lines are parallel, which means this is also 30. I shouldn't have drawn this high. Sorry, yeah, let me rub this off. Okay. So if this is 60, this is 30, 30, and we know this is the right angle, that means, hold on. Sorry? Oh, you wait for, I think it was when I think you wait for okay. And so we have 30, 30, 90 degrees. That means this is 90, right? But inside here, this green and red line, this one, this triangle, this is 60. So you see, right, this angle of 60 will always affect this angle, 60. If this was not 60, this was 30, it would be 30, then 30, 60, 60, 30, 30, 30. Then if this was 45, 45, it was 70, it'll be 70. So I'm going to rub this off because I don't want you to get confused with this. We focus on this fact that this side is 60 and 90. So this, whatever angle this is, it will be like this. Now, how to find the value of Wx and Wy? So Wx is the opposite, right? So Wx, using Sokatua, Wx over W, opposite to 60, sine, right? So sine 60, which means that Wx can be calculated as W sine 60. How much is W? 24, right? So that gives us 24 sine 60. Sine 60 is how much? If you count, times 24, you get, I'm just going to copy the answer from the textbook, okay? 20.78 Newton. And then, give me a moment. Okay. And then Wy is adjacent, right? Adjacent over hypotenuse gives us cos 60. So that means Wy bring this up, W cos 60, which gives us 24 cos 60, and that's how we get oops, 12 Newton. So these are the values for the horizontal and vertical component. Wait, I shouldn't use this. That looks very fine. This and this. However, to solve the value of the resultant forces, so once we've got this, I'm just going to put the values in here. This is actually 20.78 Newton and Wy is 12. So you see, the reason why the normal reaction was 12 is because it is in reaction to Wy. So it's always trying to balance that value. And because it's balanced, you can see you can actually ignore the forces in this direction, which means that the answer to B, the resultant force, is only 20.78. Because it's a smooth surface, no friction, that's why nothing to minus. So that's why in the end, your answer is only 20.78. Okay. Then finally, to calculate the acceleration, it's just F equals ma, taking the resultant force of 20.78, and the mass is given as 2.4, right? I think that's the question. Yep, 2.4. 2.4a, you count bada bing bada boom, and that's how you get 8.66 meters per second squared. Okay, so that's how you solve it. Now, normally the most confusing part about the forces on inclined plane is trying to get this triangle. So once you can get a triangle as well as the angle, you should be able to solve the values already. All right, so I hope you found this helpful to help you solve the questions and your homework, of course. Let me give you the homework. All right, so your homework is to do the questions in the module book. Oops, you can't see it. Let me just change the color. Module book, page, check what page? Page 17 to 18. Tugasan 2. And we will discuss the answers in the next lesson. Any advanced reading? No, because there's homework given, so no need to do any advanced reading. Okay? Of course, anything you don't understand, we can discuss in the next lesson when I see you. Right? Okay, so thanks for watching. Okay, happy studying.